In this video, we will demonstrate effective leak checking techniques using an electronic leak detector. The key to successful electronic leak detection is to use a quality, well-maintained tool with a good leak detection process. As this chart clearly shows, electronic leak detection is by far the most effective leak detection method when compared to other commonly used techniques. An undetected refrigerant leak is one of the main causes of repeat compressor failure. This is because a leak results in the liquid refrigerant level in the evaporator falling over time, causing the oil to drop out and pool in the bottom of the evaporator, as we are illustrating here. Pure refrigerant returning to the compressor by itself is a powerful degreaser. It strips the vital lubricating film of oil from the pistons and cylinder walls, causing the compressor to fail catastrophically. Therefore, finding and repairing leaks is critically important for compressor longevity. There are several electronic leak detection technologies available. Heated diode and infrared appear to be the most common for automotive use. A quality tool should meet SAE J2791 for R134A detectors and SAE J2913 for R1234YF leak detectors. Most modern detectors will detect both refrigerants. These standards mandate that the tool must have at least 3 manually selectable leak detection scales to help differentiate between small, medium, and large leaks. A decal on the tool should indicate that it meets both SAE standards. Remember, R1234YF is classed as mildly flammable, so you should only use an approved leak detector. So let's get ready to look for leaks. All detectors require regular maintenance, including replacing the probe filter and sensing element at the recommended intervals. A degraded sensor that has exceeded its effective service life is a common reason for poor leak detection success. The sensing element of even the best detectors degrades over time. To find those tiny leaks, the sensitivity of your detector needs to be as sharp as possible. Therefore, it is important to regularly check the sensitivity and accuracy of your leak detector against a calibrated reference leak. Most quality leak detection tools come with a small vial of reference leak refrigerant. The vial has a finely calibrated reference leak of about 5 grams per year. You should regularly test your detector against this reference leak to confirm that it is still capable of detecting the very smallest leaks. For successful electronic leak detection, it is absolutely vital to stop all airflow across the vehicle. This is key. Any air movement across the leak area will disperse the few molecules of refrigerant that may be present, and you will never find the leak. If possible, you should close all shop doors and windows, turn off shop fans and air conditioning, and of course, the vehicle itself should be off. To start leak checking, there must be a minimum of 50 psi in the system. Even if a system has some pressure in it, you may want to confirm with the refrigerant identifier that it is actual refrigerant. Raising static system pressure significantly will greatly increase your chances of finding a leak. We will explain methods of raising static system pressure shortly. As we mentioned, an electronic leak detector has 3 sensitivity settings, calibrated for small, medium, and large leaks. Start with the highest sensitivity setting. If the tool appears to trigger too soon, move to the next sensitivity setting, and so on. Oil in the system can mask leaks. Wait for at least a half hour after the compressor has been shut off before starting to leak check. This allows the oil to drain down inside the system and will often reveal hidden leaks. Systematically work your way around the system. Hold the tip of the detector as close as possible to the suspected leak site, within 3/8 of an inch. Move the tip along at about 1 to 2 inches per second. Focus especially on likely leak points, such as hose and line couplings and crimps, compressor case joints and front seal, and the condenser, especially low down in the front of the condenser where debris damage and corrosion are common. Spring-lock couplings are especially prone to leaks because they allow movement during normal operation and are therefore prone to wear. We will discuss specific evaporator leak checking techniques in a moment. Refrigerant is heavier than air and will tend to drift downward. Check particularly carefully along the underside of components. If you find a leak, continue to check the entire system. It is common to find additional leaks, especially on older vehicles. Check carefully around pressure sensors and switches. They are a common source of leaks. Unplug the electrical connectors, as refrigerant often leaks past the electrical terminals where they pass through the plastic molding. To check for compressor front seal leaks, operate the air conditioning system for several minutes and then, with the engine off, place a shower cap over the compressor nose. After 15-20 minutes, introduce the tip of the detector into the bottom of the shower cap. If the front seal is leaking, the detector will almost certainly alarm. If you are having trouble localizing a leak because the entire area is saturated with refrigerant, try blowing out the suspected area with shop air and then recheck. Now let's discuss techniques to improve our chances of finding an evaporator leak. The key is to raise static system pressure, especially on the low side of the system in the evaporator. Begin by parking the vehicle outside in direct sunlight with the doors and windows closed. Set the mode controls to vent and system to recirculate. As you park the vehicle, be sure that the compressor and blower are both off. This is important. After a short while, on a hot summer day, cabin temperature can easily exceed 120 degrees. This would raise static system pressure to 150 psi or even more. The increased pressure, especially in the evaporator, will accelerate the leak rate and cause refrigerant vapors to accumulate rapidly in the evaporator case. Enter the vehicle quickly but smoothly, creating as little air disturbance as possible, and bring it inside. Be careful not to turn on the blow motor or the compressor to avoid disturbing refrigerant vapors that have accumulated in the evaporator case. Raise the vehicle on a lift and introduce the probe of the electronic leak detector to the evaporator drain. Since refrigerant is heavier than air, any refrigerant vapors present in the case will be seeping from the drain and will almost certainly trigger your detector. Caution: be careful not to allow water or debris from the drain to enter the tip of your detector. While the vehicle is raised, check any other components that are easier to access from below, such as the bottom of the condenser and low mount compressors. If accessing the evaporator drain is difficult, try checking from inside the vehicle by removing the blower motor resistor from the evaporator case and inserting the tip of the detector probe through the opening. Angle the probe tip downward toward the bottom of the case where the heavier refrigerant vapors will be concentrated. Yet another method is to place the tip of the detector probe into the center duct closest to the evaporator. After you have raised static system pressure, as we described earlier, and the system has been sitting off for a while, briefly blip the blower motor on for just a second or two. Any refrigerant vapors which have accumulated in the case will be pushed out the vent and will trigger the detector. To raise static system pressure in colder weather, run the engine with the AC off and the system set on high heat, recirculate, with the hood closed. This will warm all air conditioning components in the vehicle, including the evaporator, which will significantly raise static system pressure. Before we finish, here are a few tips about refrigerant leak detection tools. Most tools take time to warm up before they are ready to use, usually about a minute. Most infrared detectors acclimate or zero themselves to the background refrigerant level every few seconds. They only respond to the changing concentration of refrigerant in the air. Therefore, it is important to keep the tip of the detector moving back and forth across the suspected leak point. If you let it sit over the source of the leak for too long, it will acclimate to the local level of refrigerant concentration and stop indicating a leak. If you are not familiar with this feature, it can be confusing. It is a good idea to zero the detector occasionally by moving it well away from the suspected leak area for a moment and then rechecking the suspected leak site. On some tools, like the one shown here, the auto zero feature can be temporarily disabled, and the tool manually zeroed to the ambient background refrigerant level. This tool also has a cloud hunting feature, which displays a continuous parts per million readout. This makes it easier to tell if you're moving toward or farther away from the source of the leak. Keep in mind that most tools can be false triggered by certain chemicals such as washer fluid. Check your tool's user guide for a list of these chemicals. When you have found and repaired the leak, don't forget to install new Schrader valves and service port caps. Service ports are a common source of refrigerant leaks. And a final reminder before we go. Don't forget to check that your detector responds properly to a reference leak and replace the filter. Thank you for watching.